In this lesson, we'll talk about handling exceptions within our applications. Now, what is an exception? Well, a very simplistic way of looking at it is something unexpected that happens while your application is executing. And while this has become the default definition for the term, it's not entirely accurate. An exception is a special kind of an event that's raised by a method in a class. Now, whether that class is in the .NET Framework or a class that you create doesn't really matter. It's an event that's fired because it either meets some condition or doesn't meet a condition that was expected. It's up to every method of every class, whether we're talking about classes in the .NET Framework or even classes that you create, to decide when and why to raise an exception. Now, usually it's because there's something about the state of the application or the values that were input into the method that are somehow invalid, although that's not always the case. But at any rate, when this happens and it's impossible for the method to continue executing, the last thing that it can do is throw up its hands and raise an exception, hoping that the code that called that method can gracefully handle the situation. So what happens is that you have a method. Let's say the button one click event that we've been talking about up to this point. And the event handler calls a method of some class in the .NET Framework. Now we can build on the previous lesson. Let's say that this is the constructor of the system.xml.streamReader class. And we pass in an invalid file location to the constructor. And obviously there's a problem because the StreamReader class can't continue on, so it throws an exception. And think in terms of throwing and catching a ball, for example. The stream reader has to tell your code that something was wrong and that it couldn't continue executing. Uh, so it bundles up all the information that it can ascertain into a special object called an exception object. The exception object is then passed to the code that originally called the method, hoping that it will know what to do. And the code you've written that calls the StreamReader's constructor method can just ignore the exception, or it can handle the exception. Now, up to now, we've just been ignoring all the exceptions, so our code hasn't been very robust. It's easily breakable. However, we can write some special code that checks just in case something bad happens as we're calling the StreamReader method and ensures that if something bad does happen, our code can handle it. We do this by using a try-catch statement within our code, and we'll look at this in just a moment. So when we write code, it's up to us to identify those lines of code that might be easily broken and make sure to add these try-catch statements around them, and I'll talk about how to identify them also later on in this lesson. Let's talk about this exception class for just a moment. The exception class is the base class for all exceptions. So we've already encountered a few exceptions. For example, in the previous lesson we saw the file not found exception that was thrown whenever the .NET Framework tried to open an XML file but it couldn't find it in the directory it expected to find it in. The file not found exception derives from the system.exception base class. Now, why do you have to use specialized versions of the exception class? Why not just use the exception everywhere? It's really so that your code can determine the exact nature of the problem and respond to it accordingly. For example, if the exception is of type file not found exception, then there's an easy remedy for this problem. You tell the user, and then you allow them to find the file on their hard drive using some type of dialog. Or perhaps the file is corrupt. Then there's a different exception for that, which requires a slightly different error message to the end user, and perhaps a slightly different remedy in order to fix the problem. Or perhaps the file doesn't contain any XML, or any of a number of possible problems that could occur. Having these specialized versions of the exception base class allows you to pick the right course of action and then try to handle it within your application if possible. And if it's not possible, then you can tell the user that the problem, what the problem is, and ask for their intervention, like please pick another file. So in the .NET Framework, there's dozens, if not hundreds, of different exceptions that have been defined that are all deriving from the system.exception base class. And whenever you create your own applications, your own classes, you can create your own specialized versions of the exception-based class. Now, we're not going to talk about how to do that in this series of lessons, but on www.learnvisualstudio.net, we talk about that at great length. So let's continue on. let's talk about a best practice, and that is that you should anticipate the problems that can occur within your application. When you anticipate what those problems are, then you should write try-catch code around those possible problems. And if you can resolve the problems without the user's involvement, then that's great. That's what you should do. If the problem requires the user to intervene, like please pick another file, then that's okay too. But you should never just allow the application to break and leave the user confused about what to do next. So let me give you an example of what I mean. We're going to create a little application that will intentionally be easily broken and look at what happens whenever we don't handle the exceptions. And then we're going to wrap some try-catch statements around the code and see how to handle the situation a little more gracefully. So you see that I've taken the liberty of creating a new project called l11. It's a simple Windows Forms application. And here I'm going to put a button, and I'm going to put two text boxes. And this is going to be just a simple calculator that will allow us to add two values together or multiply two values, whatever we choose to do here. So let's just drag and drop our two text boxes. Okay, and I'm going to double click on my button, and here I'm going to paste some code in. Okay, so you can see here that what I've done is to create a value called result, and I'm going to multiply text box 1 times text box 2 after parsing the values in text box 1 and text box 2 to integers. And then I'm going to show the results into a string. Then I'm going to finally, in the last two lines of code here, clear out the values in the text boxes. Now, obviously, this can be easily broken because all I would need to do is put in any alphanumeric character, not just a numeric character, and we've got problems. Okay, so this works well, but this will not work well. And you can see once we're in debug mode of our within our Visual C# 2005 Express Edition IDE, then I'm going to get a real pretty message here that a format exception was unhandled. Now, what will happen here is that our end user will not see the same pretty message. So let's go ahead and stop the application right now, and let's find it on our hard drive by navigating to our Visual Studio 2005, our projects, lesson 11, and then going into the bin directory, debug, and we're going to double click our lesson11.exe, and let's see what happens here. I'm going to put in A and then the number 7. And you can see that I get this very, very ugly .NET generated exception message. And you can see here that you can find details, but it's still not very useful to an end user because there's a lot of information here that they would have absolutely no idea what it means. Okay, so you don't want your end user to see this. You'd probably prefer to put a more friendly message box that says, look, you're not using values that are acceptable to this application. Try using numeric values only, or something to that extent. So let's go ahead and quit that, and then rewrite our application or add some exception handling code around this so that we can make this a little more user-friendly. The way this problem can be remedied is by using what is called declarative exception handling through the use of the try-catch statement as we've indicated earlier. The try statement defines a code block that is watching for exceptions as they happen. If an exception is found, then the code execution is diverted from the current line of code to a catch statement. And you can have more than one catch statement to catch more than one specific type of exceptions, or you can handle all the exceptions by just catching the base system.exception class. So let me show you how to do this and rebuild this example so that we can take advantage of this. I'm going to just drag a second button, double click it, and now I'm going to paste some code into my button to click event. Okay, this time we still have on the first line the creation of our result integer. And the next line of code is a try statement with an open and close curly brace. Between that code block, we have the two lines of code that we saw in the previous example, result equals int.parse text box 1, and so on. where we're multiplying text box 1 by text box 2, grabbing the result, and in the next line of code displaying it in a message box. Now, if there's a problem within that try block of code, then an exception will be thrown, and now we're able to catch the exception. You can see here that I'm just catching a general exception, the base class. This will allow me to catch any exception that happens. Now I'll show you why we'll want to be more specific in just a moment. But you can see here that if there is a problem, then I'm going to display a message box and just assume what the problem was. There was a problem with your entry, and so on. And then finally, the last two lines of code is where I clear out the text boxes. Let's run the application one more time. And this time, whenever I use a alphanumeric character instead of all numerics, I get a message box that's a little bit more friendly. There was a problem with your entry. Please make sure you use numerical values. Okay. So we're able to handle this more gracefully. My application is still running, and the user knows now that they can't input alphanumeric characters. Now what I can do to even further extend this example is to add another catch statement. As I said just a moment ago, you can add multiple catch statements in order to narrow down the exact problem that happened within the try block of code. So here we go, catch, and we're going to use the format exception and define a code block for that. I'm just going to copy this message box that we used here, but this time I'm going to change the general exception to remove some of the more specific text, because we really don't know what the problem was. So I'm just going to, we don't know, whoops, we don't know what the problem was, and I think you'd probably want to be a little more specific than that, but that's the gist of what's going on here. So let's set a breakpoint here within our code, save it, and then run our application. And this time I'm going to type in A and 7, and then click button 2. And now you can see that I'm stepping through code. I'm going to use my step into button. And notice that immediately it jumps to the format exception catch block. Where our error message is displayed. And then it just hops over the next catch block because we have found the most specific version of the exception as opposed to the most generic. And then we can just continue on. I'm going to hit F5 on the keyboard to continue on. Okay. So that really brings up a best practice, that I want to try the most specific exceptions first and then the most general last. So you can see here that I'm catching format exception, and if there were other expected problems with these lines of code, I could add additional catch statements. Finally, I'm using the catch statement that catches the general exception, exception EX, for the most generic exceptions that can possibly happen. So the question comes up, first of all, how do you know what exceptions can possibly happen within your application? And that comes down to good testing. Whenever you're developing an application, you want to test and test and test the application. Be devious and think of all of the ways to break the application. Putting in too much information in a text box, putting too little or no information in a text box, using characters like alphanumerics and underscores and the @ symbol and all the different types of things to try and break your application. And there's dozens and dozens of ways that we can break even the most simple application like this. So it's up to you to become creative, and if you're not working within a team of developers, it's helpful sometimes to have a friend or two use your application for a while and see if they can break it. This is sometimes known as beta testing your application, by rolling it out to a select few individuals who would be willing to use your application for some time before you offer the application to everybody that you know or everybody that's interested in using the application. And many of these types of things will come out during that type of testing. And you can then take that opportunity to recreate the problem as you're testing on your computer and find what the specific exception is that was triggered, and then catch that And ideally, in this instance, what we would want to do is just report the problem back to the user, but you might have other creative ways to handle the problem. Maybe you happen to know that they were trying to hit, instead of the letter A, the number 1. That's a big assumption for this particular application, but perhaps if a file is missing that was expected, like we saw in the previous lesson, maybe you can look at the parent directory or and then ask, is this the file that you meant to use, or something along those lines. But find a creative solution to the problem, and if, again, the problem can't be remedied without the user's intervention, then bring the user in only after you've exhausted all the possibilities. Okay, so you can see how to use the try and the catch statement. Let's now talk about throwing exceptions from a custom class that you build. So to illustrate this, what I've done is create a class called myClass. And in the definition of myClass, I have added a single method that returns a type double called myMethod that accepts a type double taxable amount. Then what I do is I check the value of the taxable amount, and if the value is greater than 100,000, then I throw a new instance of the argument out of range exception. Now, how did I find this? Well, quite honestly, I just went through the IntelliSense and found an exception that already existed that kind of had the covered what I wanted to say within my exception. But I could have picked one of a number of different exceptions. This one seemed to fit the best. You can see that I did something a little bit different in the next example where I made sure that taxable amount is not less than 0. If that's the case, then I just create a generic exception, just the base class exception EX equals new exception, and then I pass in a string, which is one of the overloaded constructors for the exception object, and that string represents a message that the calling code can take a look at and then display to the end user, or just ignore it, log it in a log file, whatever the case might be. If both of those tests are successful and we are able to then execute the return statement at the very bottom, then we'll just return the taxable amount times some tax rate, in this case 0.075. Next, I've added a button called button 3 to my designer surface of my form. And then taking a look at the click event for button 3, you can see first of all that I've created a variable called taxable amount that I retrieve the value of text box 1 into by parsing it into a double. And then I create an instance of the myClass class that I created, and then I create a variable called result that I'm going to retrieve the result of my method into. Then you can see my try statement where I am setting the result equal to myClass.myMethod passing in taxable amount. Then I simply display it in a message box. Now, the next two statements are where I'm actually catching the value from my class if the user were to type in a value that exceeds the ranges that I have set forth within the myMethod method. I can check for the argument out of range exception, or as you can see here, I just, in the second case, check for just the general exception. And in that case, I don't really know what specific message to tell the user, so I'm going to depend on the message property of the exception to display to the user. This probably isn't the best idea, but it illustrates how to retrieve the message property from the exception object. At the very end of my catch statements, you'll notice that I've added a new construct to our try-catch statement, and that is a finally statement. And you use a finally statement to execute no matter what the outcome is, whether the try statement's executed successfully or whether it was interrupted and a catch statement was executed instead. The finally statement runs in either of those scenarios. It runs no matter what. So in this case, what I want to do is set my instance of my class equal to null, which essentially then indicates to the garbage collector, the .NET framework, that it should be taken out of memory. Now, it's not completely necessary that I do that, and I haven't shown you how to do that up to this point, but it is something that's considered a best practice to do once you're finished with your objects, to set their references equal to null. So now let's do this. Let's set a breakpoint here on this first line of code in our button 3 click event, and then run our application. We'll put in some value, first of all, something easy, 25,000, and then I'm going to click button 3. And we would expect this to execute successfully. You can see now we're going through and checking the value of taxable amount. And so it will return successfully in a message box the value of the tax, 1875. Very good. And we'll just continue to run our application. Now let's put in a value of negative 50 and see what happens. Click button 3. We'll step through our code again. This time it should pass the first test, but it won't pass the second test. So an exception object will be created, the message will be set in the constructor, and then it will be thrown to the code that called it, which is back in our button 3 click event. And you can see here that we are going to then display the message property of the exception object that was thrown back to our button 3 click event in a message box. A taxable amount must be larger than 0. Okay, and then it continues on. Finally, just for the sake of completeness, now let's do something like 110,000. Let me count the zeros. Yeah, that looks right. And then click button 3. And now we will run this again. And this time, the first check to make sure that taxable amount is not greater than 100,000 will fire. And we'll throw a new argument out of range exception. And you can see that that is then caught. The message box is displayed. And then we're going to execute that last line of code. My class equals no. And then finish executing. Now that I've taught you all the neat features of the try-catch statement, you might be tempted to put them everywhere in code, but I would discourage you from doing that. The reason why you don't want to put the try-catch statement around every line of code that you write is because it is expensive in terms of processing power. It'll make your application slower, and quite frankly, you don't need to wrap every single line of code that you write in a try-catch statement. You should only wrap those statements that have a propensity to blow up. So for example, you'll notice in some of the code that I've written, like for example this first line of code within the button 3 click event, that I didn't include this in the try catch statement, where I'm taking the taxable amount equals double.parse textbox.1.text. Okay, maybe this would be a good place to put a try catch statement because I need to determine whether or not the value is alphanumeric versus a numeric value that can be easily parsed into a double. So that might qualify because we are depending on the input from the end user. However, the creation of new classes, like I've done here in the next line of code, my class equals new my class. We wouldn't need to wrap that in a try-catch statement, nor do we need to wrap the next line, because these are not lines of code that would be easily broken within our application. Now, whenever we're calling the myMethod method of the myClass and sending in the taxable amount, we happen to know that there is some error checking that goes on, so that might be a good place. But we really don't need to put the message box within a try-catch statement because that is something that can usually be executed without any problems occurring. So there's some discretion that needs to be used whenever choosing the lines of code that need to be wrapped within a try-catch statement. And select those things that either accept input from the end user, rely on some external resource, or where there's some value checking that needs to happen. There's some sanity checking within the object itself that we are calling a method of, so that we can then process what happens if that call doesn't work correctly. So if it's something that we can handle ourselves, we don't need to wrap a try-catch around it. But if we're relying on some external resource or the method of some class that we don't control or that we don't know how it works, then we may want to wrap that within a try-catch statement. So just whenever you're writing your code, be very conscientious about what is this line of code doing and how could it be broken. And if you think that it can't be broken, if it's performing a simple calculation and you've already checked the values before you perform the calculation, then there may not be a reason to wrap a try-catch statement around it. However, if this has a propensity to break when you're working with files or user input, maybe you should think about wrapping it in a try-catch statement. Okay, so we've talked about quite a few things in this lesson in regards to making your applications more robust, more stable, less easily broken by introducing the concept of the try-catch statement, which is a form of declarative exception handling. We talked about the exception object and how it's the base class for all of the specialized exception classes that are used within the .NET framework. We noted that we can create our own exceptions, although we didn't show specifically how to do that. But whenever creating our own classes, we can definitely use this to throw exceptions back to the calling code of our methods within our objects. And we also talked about what happens uh, when you don't try to handle the exceptions within an application, what ugly messages your end users will see and why this is a bad idea. So if you enjoyed this video, please visit www.learnvisualstudio.net to download and watch over 400 videos just like this one aimed at all skill levels on many different topics related to C#, Visual Basic.net, ASP.NET, and more. Thank you.